and I'm Vice President of Research and Science, the American Diabetes Association. And I'm here with Dr. Jonathan Rosen, who is Director of Research at the JSRF. And we're here to talk about something very, very important, and that is the insulin. This week is an amazing, we think back to 100 years ago. This was when the first successful use of insulin happened in the world. It's a medical breakthrough. John, you want to talk a bit more about it?
Oh, I would love to. So thanks for the introduction, and thank you everyone for joining. So as Marlon said, 100 years of insulin. And then what Marlon and I want to talk about today in this conversation is sort of where we've come from and then where we're going, I think. So I think when we talk about 100 years of insulin, the place to start is with Leonard Thompson, who was the first patient to ever receive insulin for his type 1 diabetes. Now, Marlon, I have a feeling you're a little bit more of a history buff than I am. Can you talk a little bit about what happened 100 years ago?
Yeah, it's pretty cool, actually. So Leonard Thompson was like a 14-year-old kid, right? And he had severe diabetes. He was in the Toronto hospital, and he came in. He was like 65 pounds. He was losing hair. He was looking very poorly. And around that time, Banting and Best were working on purifying insulin. So earlier, like I would say that last summer, they had kind of worked out a way to kind of isolate insulin from dog pancreas. And they were able to actually give that back to a dog and show that dog could come back to health, a diabetic dog. So, and they found this like in around November time frame of that year. They saw this, and so they were allowed to kind of conduct this clinical study where they took purified pancreas extract, and this was now not dogs anymore. This was actually from cattle, from cow, and they injected, they had two injections, actually. It was the 14th and then the 23rd. The 14th they injected, they saw some benefit, but the 23rd was really when it really was amazing, because they had some additional purification and so, but it was dramatic effect on Leonard Thompson. He felt much better. His glucose levels went down. Dramatic. It was, and so it was a medical break. That day was truly a landmark in medical history to have and actually, you know, Leonard Thompson actually lived for many years after that on insulin therapy. He lived for, I think it was like 13 more years, and he died actually of I think it was pneumonia, and so it's not diabetes related at all. So and then other people were taking from that, other people were getting insulin as well. Many people, other people were receiving it. And this was actually a red letter day in that, because people before then would only live for like 1 to 2 years with diabetes. So this was absolutely dramatic.
I think that's exactly right. It's easy to forget how recently in history type 1 diabetes stopped being a death sentence. And I think that's what Leonard Thompson represents, as more than just one person who got a new treatment. It ushered in a new age of type 1 diabetes treatment, which means that if you have type 1 diabetes, you can live a long life. You don't die from the disease shortly. And this was what makes it one of the most extraordinary events in medical history, I think. And anyone watching this can Google the pictures. It's really something. Him and the other, kids back then, you can see before they receive insulin, they're very, very, very kind of skinny and sick looking. And then shortly after, you see these cute kids with kind of chubby cheeks, obviously thriving. And it was just amazing, I think.
Yeah, because at that time, the treatment was, because without insulin, they had to go on these very severe diets, strict diets, very low carbohydrate, and that's why the children at the time that had diabetes were so skinny, because they had to kind of have almost like horribly restricted diets just to stay alive, and so it was almost like a death sentence. So this insulin actually transformed transformed life for people and gave people, lives. People after that, even shortly after, there are others that were taking insulin from there because it became mass produced very quickly because it was such a dramatic benefit. People lived many years and had children and went on their normal lives. And actually too, it was that actually led to one of the fastest awarding of Nobel Prizes ever because it was so dramatic at that time. This whole such a medical breakthrough that shortly after the medical prize that the Nobel Prize was awarded. And we've come so far since then. At that time, the insulin was kind of purified from, the research was done in dogs, right? But then they found more effective ways of getting it from cattle, from cow and from pig, and so there were these bovine insulins and so on. But they, having an insulin from a different species actually kind of had an effect. Maybe some people had allergies towards those and so on. So there were a lot of kind of advances made throughout the years, even after that. So that was the main thing that happened when this injection occurred and Leonard Thompson got better. But then over the years, there were gradual improvements in insulin. So John, you want to kind of talk a bit about that?
Yeah, that's right. I think insulin's been on quite an interesting trajectory over the last 100 years. So as Marlon said, we start with dogs. That was just sort of temporary for research purposes. Then we move into pigs and cows. Then we move into the era of molecular biology in the second half of the 20th century, when scientists discover ways to make human insulin in the lab, so no blood draw necessary. They can synthesize it kind of cheaply and effectively in the lab for mass production. And now we're sort of in an even better place. People with type 1 are probably familiar with the different kinds of insulins in front of them. We have basal insulins, which you can take once a day to cover your general needs. We have rapid acting insulins, which people take at meals, and they come on fast, to cover the blood sugar rising with your lunch or your dinner. And we're going to talk in a little bit, Marlon and I, about why these insulins aren't quite good enough and the innovation we need and what we want to see in the future. But I think it is worth reflecting for a second just how far we've come since the first dog insulin was used to save a human life. And the other thing I want to point out that people, I think, don't talk about enough is how from the very beginning in insulin, there was this important role for both academics and companies. So the Bantam and Best experiments and the work to save Leonard Thompson's life, that was done at the university. And then what happened very, very quickly is the big companies came in and started finding ways to scale up insulin production for a mass market. And then very, very quickly, across the developed world, insulin was reaching people with type 1. And so I think that sort of commercial part is really almost as remarkable as the scientific discovery. And I think I would say it's still the case that there's an important place for academic researchers to discover new and important ways of making insulin better, making insulin faster, maybe making insulin cheaper. And then it's the role of the company to really jump on that, pick up the innovation from wherever they can find it, and drive it forward for people with type 1 diabetes.
Yeah, definitely. I mean, thing is, scientists are great at discoveries and finding out what opportunities are there. But then it's really the companies that that really kind of take it and then develop it and make it a commercial success, because that's the only way things move forward is that through that pathway. But yeah, no, I mean, as you mentioned, John, when they went from purifying insulin from pigs and from cattle and so on, they went to this genetic kind of like doing it in the lab. Then it allowed them to really understand, as a part of that whole process, understand the whole structure of insulin. and how they can actually make tweaks in it, either in tweaks in the structure of insulin, or tweaks in the way you formulate it to make it faster. So to make a more rapidly acting insulin, so that would be more useful for you to kind of have it's like faster response around meal times. Or they've also strategies around making modifying the insulins to make them last longer. So instead of injecting an insulin, instead of having a rapid response, which is very important that you really need, but also there's a value for having very long-acting insulin. So insulins that you would inject, that would last a lot longer time, and then people could combine combinations of insulin to kind of identify the best control approaches for them. So I mean, that was a really important step too, where when they started to kind of understand the various ways that they could actually modify the insulin, or either modify the insulin itself, or modify the way the formulation, or combination of both. And that's how kind of we're seeing all these exciting new versions of insulin, fast, super fast, even inhaled insulin, for example. And also we're seeing very, very long-lasting insulins as well. So there's so much innovation has been happening since then. It's very, very exciting.
And Marlon, would you agree if I said that insulin must be one of the most heavily investigated molecules of all time? I mean, this is a relatively small protein, and people may remember from biology class, proteins are made of amino acids, and I think nearly every amino acid in insulin has been investigated. It's been changed. It's been tweaked. They've seen if it makes the insulin faster or slower or more stable or less stable. They know what the three-dimensional structure of insulin looks like. And so the innovation we see in insulin, I think, is the result of 100 years of intense investigation. Again, creative academics, doctors, chemists, molecular biologists, and companies working together to make this really sort of the golden molecule.
Totally agree. And I think a lot of the work has been towards making it more physiological, because what happens is when you inject insulin, I mean, it's insulin really comes from the pancreas, and that's the best source of insulin. You can inject insulin subcutaneously and so on, and it works really well. But the best source of insulin is actually, or the best route of insulin comes from the pancreas. So all the approaches that people are taking to modify insulin to try and make it also more physiological. Then one of the key things I think is to make it faster. The most because we hear about these like when people even see food, there's a little kind of release of insulin, for example. And we want to get to that level where insulin is so fast that the exogenous, the insulin you provide almost replicates the kind of the natural insulin you have in your body. And I think that will happen eventually in terms of as research progresses, maybe production of insulin from injecting insulin, but maybe also to other insulin delivery approaches might be an area for consideration too in their area.
Yeah, Marlon, completely agree. And I think what we're both really excited to talk about is all of the new up and coming insulins that people can look forward to. But I wonder if first we could briefly touch on why new and better insulins are needed. So, I think that the epidemiological data are clear that with the current insulins, people still aren't reaching their A1C targets, and people still have periods of high blood sugar and periods of dangerous low blood sugar. And unfortunately, some people will still get long-term complications. And all of this can be addressed with new and better insulin. So that's really, I think, all of our goal is thinking about the outcomes, the health outcomes we want to see for people with type 1 diabetes. And then the other thing that I think we have to talk about, and even though this whole conversation is in some ways a celebration of insulin, I think we have to acknowledge that insulin is a real pain. It's dosed many times every day. People with type 1 have to make dozens of decisions every day. How many carbs will I eat? How much insulin do I take to match that amount of carbs? Do I take more insulin if my blood sugar is a little bit high later? Do I have to eat more carbs if it dips low? And on and on. And so I think in addition to things like making insulin faster, like you brought up, a really important goal for future insulins also has to be making it easier on the person using it, less
Yeah.
burdensome treatment regimens, smarter insulins that take away some of the decision making from people, and so on.
Yeah, totally agree. And I think that you can work it into the insulin, which is actually a very exciting approach, but also to insulins in closed loop systems, in hybrid delivery systems. We see a lot of exciting research around hybrid or automated insulin delivery systems, where you have a pump and you have a sensor and you have an algorithm, something that kind of tries to deliver the right amount of insulin at the right time. So, I mean, what we want to do is reduce the burden so people can actually have to have optimal insulin therapy. So even before getting to the level where we can actually make the ideal insulins, there's also the opportunity to deliver current insulins actually more in a less burdensome way through hybrid closed loop systems and automated insulin delivery, and that I think is very exciting as well. And there's a ton of work going on. It's amazing how much has happened in the last years in this area.
Yes, seconding that. I mean, just in the last 5 years, there's been an explosion in the hybrid closed loop market. When we say hybrid closed loop, what we mean is a system where you have an insulin pump, a CGM, and an algorithm that speaks between the two. So the CGM notes what your blood sugar is around the clock, and the algorithm reads those numbers and tells your pump how much insulin to put into your body. And here, the insulin itself, as Marlon was saying, the insulin itself isn't especially fancy. It's the system that takes the user, some of the user burden off of the person with type 1 by making decisions for them, by putting the right amount of insulin into the right, in at the right time. These systems aren't yet perfect. And one technical challenge that we're trying to overcome is that you still need to manually input insulin with meals because the algorithms aren't quite good enough to cover a rapid rise in blood sugar that comes with the meal. But that's a goal for the future. But where we are with devices for insulin delivery, for smart insulin delivery, is just extraordinary.
Yeah.
And now,
I mean,
I was
totally, go ahead. Go ahead, John.
Okay, thank you. Sorry to interrupt. I was going to go back to a point you made, which is so important, about trying to recapitulate the way insulin works in someone without diabetes. So, the biology is that if someone without diabetes, eats an apple, very, very rapidly, their pancreas will release insulin. And so if you put a CGM on someone without diabetes, you wouldn't see a big rise at a meal because the insulin comes out so fast in the right amount. So when I think about what we need from new insulins, I think in general, the philosophy is designing insulins in a really smart way so that they act more like insulin from a non-diabetic person's pancreas, and do away with these roller coasters of insulin and carbs and insulin and carbs.
I completely agree with you. I think that's the Holy Grail, is to get an insulin that's almost like physiological, something that can be so rapid. I mean, we're seeing things that are very rapid, like inhaled insulin. I think is one of the things that is remarkably rapid. So we're heading that direction. I think things are actually quite good right now in terms of closed loop, and so I think there are challenges with meals and exercise and so on. But when we put it big in the context of like 100 years ago, this is like night and day,
Yeah.
compared to then. So it's just phenomenal progress. But yeah, no, I think one thing we really do need now to have as an insulin that's so fast that there's no delay. It's almost like physiological, like almost like how the body releases it when you have a meal. That's what we want.
That's right. Instead of timing your insulin administration some number of minutes before the meal, you just take it right with the meal and you don't get a glucose split. That's the goal. And then the term that people often hear, or people like me and Marlon use, is ultra rapid insulin or some version of that. And the good news is that insulins are getting faster. So we have rapid acting insulins, and we have newer and yet faster acting insulins, things like Fiasp and Leonjeb. But I think we need to keep pushing against that wall. The faster the better. And I think we're not there yet. We gotta keep speeding it up to get it to where naturally secreted insulin from the
Yeah.
pancreas is.
Another aspect that I think is probably going to happen even sooner is long acting insulins. So people
Mhm.
people with type 2 diabetes, for example, um, you know uh, uh, you, you know you might want to have an insulin that you don't need to inject that often. Obviously, you want to reduce the burden, so you want to have as few injections as possible, but the longest activity. And so I'm actually very excited about these like long acting, like once a week injectables. And all these kind of amazing ideas we're hearing. I don't know how soon they'll be all available, but incredible strategies kind of like do um, long-term, week-long injectable insulins, even oral insulins for that matter. So there's a interesting aspect where people are thinking of how fast can they get them, and also actually how slow and how sustained can they get them as well. So lots of work around these areas, and very exciting.
That's exactly right. It blows my mind. There are once weekly basal insulins in clinical trials, I believe. Um, and it's just really exciting. What it means is that someone with type 1 in the future might be able to take one weekly shot, and that's their basal, and then a super fast acting one with their meals during the day. And that's if they're an injection user. If they want to use pumps, then they have yet more options for how to manage. And the oral insulin thing, I think, is really important too. Technically, it's an amazing challenge that scientists are trying to overcome right now. But I'm hearing some optimism in the field that oral insulins can be a reality in the future also.
Yeah, I mean, going back to what you said just now, John, about this being one of the most uh, studied
Mm-hmm.
studied proteins, studied hormones in the world. That's actually a great thing for diabetes because the future is bright because there's so much effort and so much interest in actually modifying insulins and trying to make them work better in people. I think one area too that's kind of interesting is this idea of a co-formulation of insulins as well. Where you
Yeah,
can actually add things to. You want to talk about that, John?
yeah, it's one of my one of my favorite things to talk about. So this touches on the concept of what we call adjunctive therapies, which means drugs that can be taken not instead of insulin, but along with it to help people improve outcomes. And one drug that comes to mind is called pramlintide. It goes by the commercial name Simlin, and this is a drug which is actually approved for type 1 diabetes. And we know it lowers A1C and has other benefits, but very, very few people have ever taken it. And one of the reasons is that it's sort of a bear to take. You have to take an extra injection with every meal, and no one wants twice as many injections in their life on top of insulin. And so, something we're very interested in is insulin pramlintide co-formulation. So, for your mealtime insulin, you can take one injection or one administration from a pump that has both drugs, and then you get more benefits than you can from insulin alone with no additional user burden. And going back to the point I was making about hybrid closed loop systems, and we still haven't quite got the mealtime piece down. Both insulin pramlintide co-formulations and ultra rapid insulins have the potential to help us make algorithms that can, as we say, fully close the loop, um, meaning do away with the need for users to put in insulin boluses themselves.
Very exciting. I think there's so many strategies that people are thinking about in terms of insulin. And we think about ways in which you could, for example, modify the insulin structure itself,
Yeah.
formulate it differently, add co-formulation of other hormones as well to it. So very exciting, very interesting, and I think the future is really bright. I think also, I mean, what's also exciting, very exciting. We always think about insulin, but I think in the future, I think probably the best insulin will be the insulin that comes actually from beta cells.
Mm-hmm.
You know,
Yeah, completely agree. When we think about the future of insulin, um, at the risk of sounding glib, the future of insulin is no insulin. The future of insulin is that organizations like JDRF, like ADA, and others are working toward permanent cures for type 1 diabetes and permanent prevention strategies and beta cell transplants and things like that. And so the total future of insulin is that you don't have to take insulin. But until we get there, I think new and better insulins are going to be absolutely essential for
Sure.
diabetes care. And Marlon, can I run my mouth just for a moment about liver targeted insulins, which is another
Good
topic I'm
idea.
excited.
Yeah, that's a very important area.
So one of the functions of the liver um, is to regulate your blood sugar. And unfortunately, the way current insulins are taken when they're injected beneath the skin, not very much insulin gets to the liver, so it can't really do its job. And so some people are working on liver targeted insulins, and these are actually in clinical trials where the insulin is made in a special way so it'll be injected at the normal site under the skin, but then home to the liver and do its thing there. And then this, we think we'll be able to improve blood sugar, prevent hypoglycemia, and have a bunch of other benefits. And this is one more example of how the next generation of insulins, we want to be more like natural insulin secreted from the pancreas. In someone without diabetes, when the insulin is secreted from the pancreas, it goes straight to the liver. That's kind of the first stop, just because of how the organs are placed in the body. Um, the body wasn't really designed to take insulin under the skin on the abdomen or anywhere else. So a liver targeted insulin, or LTI, is one way we can kind of reproduce natural physiology, as you were saying, to get superior outcomes.
Yeah, I think that's very exciting. Yeah, that's your point is so well taken that the pancreas delivers the hepatic portal vein that goes to the insulin goes to the liver. So basically, if you can actually engineer an insulin so it goes to the liver, you're going to have a lot more efficacy there. I see we have a question in the chat here. Can adjunct therapies help increase insulin efficacy? Do you want to take that, John, or shall I take it?
Sure, I'll give it a stab. I think the answer is yes. There's many different adjunctive therapies that people are experimenting with and driving forward for type 1 diabetes. And again, adjunct therapy means non-insulin drugs you take along with insulin. Some may have the potential to make insulin more effective in the sense of reducing insulin resistance, which means how your body responds to insulin. So if you take an adjunctive therapy that can improve your insulin sensitivity, then the same amount of insulin you take will pack more of a punch, and that's a good thing. There are other adjunctive therapies which work in what we call an insulin independent way, meaning they lower your blood sugar sort of regardless of how much insulin you have in your body. And I think both are going to be very important for getting outcomes and people with type 1 to be as strong as they can be.
Yeah. We talk about insulin and insulin being produced from the pancreas, but what I find very interesting too are the incretins. The gut is an amazing source of hormones, and we're learning more and more about how these are involved in glucose regulation and so on. So, I mean, we're hearing about these, and I think that might be an area too where not necessarily even co-formulation, but actually adding these into to your therapy regimen actually may have some significant advantages. So there's so much to learn, and I'm truly absolutely fascinating where research is heading. Not just in the kind of modification of insulins and making them more effective and so on, but yeah, adjuncts to it, other molecules, other hormones, better ways of actually reducing the burden of using insulin, making it more easy. A closed loop, for example, insulin pens. Um, we should also kind of mention CGM, how valuable that is to help you decide when to deliver insulin. And people, when they wear CGM devices, they get a better sense of when they need to take insulin and how better to control. We're seeing lots of benefit there. Even with existing insulins, we're seeing that people are able to control their glucose. So there's so much that goes into insulin therapy and taking care of blood glucose. It's it's quite amazing how much we know now and how much we can move forward with. But yeah, the future of insulins, I think these are going to be very interesting. You know, liver targeted insulins, um, and I think what's very interesting too, and it's absolutely fascinating. And I know it's probably a few a ways to go, but glucose responsive insulin. That's a fascinating area. And I know everybody's interested. John, you want to talk a bit about that?
Yeah, thank you for bringing it up because I really think we would be remiss if we didn't speak about it because it's such an extraordinary concept. So the idea with glucose responsive insulin, which we call GRI, is an insulin which is active at high blood sugar, but automatically becomes inactive at low blood sugar. And so it's a little bit like a fully closed AP system, except it's in drug form, so you don't have to wear devices. So imagine it this way. So you wake up and you inject your once daily glucose responsive insulin or GRI. If you wake up and your blood sugar was high, the GRI will bring it down to a certain blood sugar level. I don't know what exactly, let's say 110, something, some place where you want to be. And then once the blood sugar gets to that point, the insulin will turn off without you having to do anything. Inside your body, it'll turn off. So your blood sugar won't go into hypoglycemia. And then maybe at lunch, you eat a sandwich, your blood sugar starts to rise. And when it hits a certain point, the insulin turns on again. So throughout the day, glucose responsive insulin will turn on and off as you need it to handle your blood sugar. And this is why you sometimes see it called smart insulin. We always say the insulin does the thinking for you. When this works, and we're seeing a lot of progress, which Marlon and I could talk about in a moment. When this works, what we'll see is a drastic reduction in the user burden of having to deal with insulin. There will be a reduction in carb counting and insulin bolusing and having to deal with postprandial delayed hypoglycemia and lots of injections every day and all of that because the GRI should be able to handle that. I know people are often interested in hearing where we are with GRI. So there's a number that are in preclinical development, and there's one that we actually know has already started a phase 1 clinical trial, and that's sort of relatively recent news. And so I think there's this is the future of insulin. This isn't going to be ready tomorrow. And we always say drug development takes a long time. It's difficult. Everyone knows that, and it's important to remind people, but still, this approach has extraordinary promise, and I think there's lots of reasons for optimism in the field right now.
It's so exciting to hear that people seriously working on glucose responsive insulin because I mean, what you want to do is deliver the right amount of insulin at the right time. And one of the reasons why a lot of people don't have good control is because they're concerned about hypoglycemia, for example, and if you had an insulin that could kind of turn on and turn off and become available only when you needed it, and that's the ultimate goal of insulin therapy. So I know, I mean, it's high risk, high reward, to do these studies. I mean, but the fact that so many bright people are working on it and thinking about it, and actually these are starting to go to clinical trials is very, very exciting.
Mm-hmm. No, it really is. And Marlon, I'm going to read a question I see came in, which I think is interesting. It says, if you two have type 1, how do you manage it? And I actually don't have type 1, but the reason I want to ask that question is to make the point that it's going to be different for everyone. What I mean is what's best for each person is going to be unique to that person. I think that's part of our goal here, both with insulins and adjunctive therapies and pumps and AP systems, is to create a menu of items that people can choose for how they manage their disease. Some people want a pump and some people don't. Some people are, uncomfortable with AP systems and some people, swear by them. We actually know that some, brands of insulin work better in some people than other brands do. There's just so much unique experience with type 1 that I think one of our goals is not just to make, the best insulin for the future, but lots of different types of insulins and adjunctive therapies and devices so people can pick and choose and tailor their therapy for their own needs.
Totally agree. I think again, it's very tailored to the individual. I know my cousin who has type 1, he likes to use a CGM in his pump, and he's looking forward to the closed loop system, the automated insulin delivery. I know, but the other people that are quite happy, kind of wanting to going forward with insulin therapy and injections and so on. I think one thing that's really valuable is to kind of to wear a CGM. Whatever you do, actually, I think wear a CGM, because that helps you kind of understand how the glucose response is and so on, and research has shown that people are better able to control their glucose with that kind of information.
That is so true. I mean, CGMs, yes, everyone, we should strive for everyone to be on CGMs. I'll put it that way. There's so much data showing how these devices improve blood sugar and outcomes. So I completely agree. One question I'll just speak to quickly: GRI is via needles or also used with pumps. It'll probably be, it's interesting. There's some discussion if you put a GRI, which is sort of like a closed loop system already, and you put it in a closed loop system like Medtronic or Tandem, will you get sort of a doubly effective system? And the answer is maybe. I think we're not really sure, but I usually think about GRI as being by injection, something like a once daily injection that'll allow people to go without devices and additional insulin. But the other way may be feasible also.
Yeah, but I think what we should emphasize too, that as we're waiting for the newer insulins like GRI and so on, it's important for everybody to remain healthy until we get that. So maintain tight glucose control, leverage everything's out there. For example, the automated insulin delivery devices, CGM, and so on, because these things are coming. You're not sure when, but and also two things like insulin delivery from healthy beta cells restored into people with type 1 and potentially type 2. And so in the future, I know that insulin beta cells, we're worried about obviously the immune response, the immune attack, and so. But look at all the exciting work that's going on about kind of having organs and tissues evade immune attack and so on. I mean, it's really amazing what the future might hold for diabetes as well.
It's amazing. So one quick note, I see we were throwing around an abbreviation. So CGM stands for continuous glucose monitor. This is a thing you put on your skin, and instead of just testing your blood sugar, when you choose to, it continuously gives you glucose information, which lets you make better decisions. And so Marlon, I thought for fun, I could try to sort of summarize all of the insulins from beginning to end. So tell me if I'm missing any. So we start with dog. We go dog, pig, cow, human in the lab, basal, rapid acting, basal and rapid acting, and that's kind of where we are now. And then we can look forward to super long acting insulins, ultra rapid insulins, oral insulins, liver targeted insulins, glucose responsive insulins, and more and better devices to use insulins in, and adjunctive therapies to complement insulins. Did I miss anything? Is that 100
No, actually, I'm sure there's new things that are coming on the pike as well, because there's so much work in this area and so much focus, and so much innovation, especially with research, supportive research, and so on. Actually, it's quite amazing, and I'm surprised every day at how much cool stuff is coming on the pike. But I think you've covered most of it. It's definitely exciting. I think the future is bright. I think this just is so good to have all these bright scientists and researchers and companies as well focused on improvements and innovation, and so to kind of try and get insulin as physiological as possible. Better delivery, reducing the burden. So when you think about 100 years ago, where things were at, where it's just kind of having people survive, to the point where having people thrive now, and continue to thrive. That's amazing.
Completely agree. It's so exciting to see what the lives that people with type 1 can have that would have been unimaginable 100 years ago, or even 50 years ago. That we're on this wave of progress, and it's I think time to keep riding it. So Marlon, I think we're in a pretty good place to kind of wrap up this conversation. Do you have any parting remarks?
Oh, just to say, tell everybody, this is so much work going on. There's a ton of research. There's a ton of potential. Um, I just, I'm just amazed at the amount of science and research going into innovations in insulin delivery. And I have my fingers crossed for glucose responsive insulin, because that's such a cool area. And I'm hoping for that the trials and the initial work will actually pan out and people will get to use it. But I mean, even then, even while we're waiting for that, we have a huge opportunity to kind of leverage all that's out there to kind of improve glucose control and to prevent any kind of complications until a cure is found.
Completely agree. I would say we've done a lot in the last 100 years, and we're going to do a lot in the next however many years it takes. And then the ultimate goal is going to be no one taking insulin at all. So thank you, everyone, for attending. We encourage people to check out our websites. The JDRF website is jdrf.org, and the ADA website is diabetes.org, where you can learn more about insulin and what we're all doing to advance their cause and improve outcomes and improve the lives of people with type 1 diabetes. Thank you very much.
Thank you very much. Great chatting with you. All the best.